Hello, my name is Jatin Pal Singh, and I'm a solutions architect focused on cloud computing with a vision on innovating cloud solutions or developing cloud solutions focused on data and AI, which solve real world problems like sustainability, healthcare, security, and privacy. In this paper titled Optimizing Data Center for Sustainability, the role of serverless fog computing in artificial intelligence, I go over how the concept of fog computing applies to the serverless architecture and within the data center space, how this design can be used for sustainability or reducing carbon footprint. In the paper, which is published in International Journal of Science and Research, as you can see, I go over the details of how the modern day data centers are becoming energy behemoths with explosion in the requirements of data, massive data which is being used across the globe in different industries like healthcare and computing requirements for AI in spaces like retail or in spaces like life sciences, where a lot of artificial intelligence and a lot of machine learning algorithm need huge computing power and huge storage power. The usage of data center has exploded, and large cloud computing providers provide a lot of these data centers, as you can see within the cloud space, right? So I go over this a little bit in this research in the first half, going over how this energy requirement over the last decade is increasing and how it is impacting the carbon footprint. The research also delves into the importance of sustainability and goes into key concept on how we measure the impact of this energy consumption, quantifying them into different aspects. Once we lay the foundations of why the overall subject makes sense, and how sustainability and why we picked up the topic of data center and how it impacts the carbon footprint, we go into a concept which is the core of this paper's proposal, that with the modern day architecture, how a concept of fog nodes or fog computing can be integrated with serverless architectures to implement an architecture which can actually significantly reduce the carbon footprint. So the paper then goes into explaining what is fog computing, which at high level is a three, it can be understood as a three-tiered architecture. So if you think of IoT devices, which are implemented in edge computing, for example, you have refrigerators or you have thermostats at home, where a lot of computing and processing happens at the edge node, and the data does not need to leave the edge node. That's the core concept of edge computing, right? And in some cases, this data needs to be consolidated back in the centralized data centers or the cloud service providers, right, to do more heavier processing on the consolidated data. Whereas in case of fog nodes, a concept of a middle tier architecture is introduced, which significantly reduces the traffic back and forth, also providing the benefits of reduced latency and better throughput, uh, and overall a better experience. So the paper argues into this, what are the advantages and disadvantages of implementing the serverless architecture within fog computing with respect to different designs, and goes into the complexities like state management and security and complexity of monitoring and debugging of each of these architectures. The paper also goes into the details of what are the benefits of implementing this design along with the challenges that we cover, and then concludes with the implementation of this design, how it impacts in reducing the overall carbon footprint and helps data center with improved efficiency. So finally, we go over the fog computing integration with the serverless computing evolution, and concluded there. The target of this paper can be those service providers who have an offering in sustainability space and want to show how within the data center architecture or space they can implement certain designs which can lead to a reduced carbon footprint. With that, I thank you very much and thanks for choosing to see this.